Now, there is a positive integer a. But if I multiply that integer a with itself n times, so what does the power of a become? I want you all to respond in the chat box whenever you know the answer, and I'll just give a good look. So the power of a becomes n. And so this index is a power n. So then let's see, this is something you've learned in maths on how indices can be expressed. This is part of simple arithmetic, that when you have 2 power 0, what does that become? 2 power 0, 3 power 0, 4 power 0, any value to the power 0 becomes 1. That's correct. But what if I have 2 power negative 3? What does that become? What is 2 power negative 3? That is 1 upon 2 power 3. Because to remove this negative, I'll take the 2 in the denominator. So if I have 5 power negative 1, that becomes 1 upon 5. And so we have a power 1 here, but we ignore that. What if I have 1 upon 2 cube? I can also express that as 2 power negative cube, or simply 8 power negative 1, because 8 power negative 1 becomes 1 upon 8. So these are all the ways I can express just one value. And why am I expressing it in different forms? It depends on the question I have. If the question has values all in fractions, so I can use this value or this value. If the question has values with base 2, then I can use this. If it has values in base 8, then I can use this. So that's how we're going to manipulate our term with respect to the question that we have. If I have 5 power half, what does that become? When you have any value to the power fraction, so the first number, the numerator, stays with the number and the denominator goes as an under root. So we have 5 power 1 and the under root of that. If I have 8 to the power 3 upon 2, the 3 stays with 8, so it becomes 8 cube, and I find the under root of that. Now, that is very simple, that's easy to understand. And so the first rule for indices is the rules for same base. So when I have the same base and I am multiplying them and they have different powers, the base is same, a is the base here, what happens? The powers get added. So that becomes a to the power m plus n. So that's very simple. If I have 2 to the power 3 times 2 to the power 2, the powers get added. It becomes 2 power 3 plus 2, 2 power 5. And you can easily find out what the value is going to come out to be. You can use a calculator. If it's paper 1, you can simply just multiply it 5 times. Okay, so the answer is 32. The next rule is that if you have the same index, so the a is the base, but m is the index. So I have different bases, a and b, but the index is same, which is m. What happens is we multiply the bases and we give them the common index m. So it becomes ab to the power m. For example, I have 3 power 2 into 4 power 2. I would simply multiply 3 by 4, which gives me 12, and give it a power of 2, which will give me 144. Okay, let's start with a question and then let's see how much you understand. So the first question that I have is of exercise 3.1, question 1a. 2 cube times 3 square, the whole having an index of 0. What value do I get? That is correct. We don't even need to multiply what's inside the brackets because we know that anything to the power of 0 is 1. Now, the next question that I have is the common base we have, the simplest base we have here is 3. So we will convert all our values into 3. So what do? 3 to the power 1 upon 3 times 3 to the power 0 times, how do we convert 9 into a form that has base 3?
3 to the power 2.
Yes, it becomes 3 square times 1 upon 3, so 3 to the power 2 upon 3. Then how do we express 27 with base 3?
3 to the power 5 upon 3.
3 to the power cube. It becomes 3 cube multiplied by 2 upon 3. So we're going to multiply the 3 by 2. That gives us 6. 6 upon 3, which makes it 6 upon 3 is 2. So that becomes 3 square. Okay, now to calculate that. Over here, since they're all multiplying, we'll add the bases. So that becomes 3 power 1 upon 3 plus 0 plus 2 upon 3 upon 3 square. And so 1 upon 3 plus 2 upon 3 becomes 1. So that's 3 to the power 1 upon 3 square. When it's dividing, we will subtract the powers, the indices. So it's 3 power 1 minus 2 and gives us 3 power negative 1. How else can we express 3 power negative 1? We can express it as 1 upon 3, because if we want to express it in terms of a positive index, so we're going to bring it to the denominator. By rationalizing the denominators, simplify the following. What is rationalizing the denominators? So let's see. The question that I have is 3 times under root 5 minus 2 times under root 3 divided by 3 times under root 3 minus under root 5. What is rationalizing the denominator? I want to remove all the under roots. I'm going to multiply it by the denominator, by the value of the denominator, but this is the denominator, but I'm going to change the sign in between. If it's negative, I'll make it positive. If it's positive, I'll make it negative. And since I'm multiplying it with the numerator, automatically it gets multiplied by the denominator as well. So let's first check the denominator. 3 times 3 becomes 9. 3 times 3 becomes 9 times 3. Where am I getting this times 3 from? Because under root 3 multiplied by under root 3 becomes 3. Then minus under root 5 times under root 5. So that becomes 5. On the top, we have 3 under root 5 times 3 under root 3. So that becomes 9 under root 5 under root 3 minus 2 under root 5 under root 3. This is simple multiplication. We're just multiplying the terms with one another. What does that become? Let's take under root 5 under root 3 common here. That becomes 9 minus 2. And this becomes 9 times 3, 27. 27 minus 5, 22. So 9 minus 2 becomes 7. And when you have 7, you multiply it by under root 5 and under root 3. And then the denominator becomes 22. And yes, correct. And since we cannot further simplify this value, so we'll let it stay like this. So our answer comes as 7 times under root 5 times under root 3, the whole divided by 22.
So first we'll rationalize the denominator and we'll change the sign.
So what am I going to multiply it with?
We'll multiply it by 2 under root 5 plus 4. So that'll become 24 under root 5 plus 4.
No, the under root 5 and under root 5 will get multiplied.
24 under root 25 plus 4. So that can become 5.
Yes, and you will multiply the 4 with 12 under root 5. So 4 times 12 becomes?
48 under root 5.
Under root 5.
Like it'll become 4 under root 4 into 5 here, so think of under root 5 becomes 25. And minus 16. For
then multiply the 4 with 2 under root 5, so that becomes
8 under root 5.
Then multiply the 2 under root 5 with the negative 4.
So that becomes minus 8 under root 5.
Then multiply the 4 with the negative 4.
That becomes minus 16.
Cancel this, plus minus, same values, cancel. What is 24 into 5?
120.
Yes. Wait, 24 into 5 is 120 plus 48 under root 5. That becomes
168 under 5.
no, this is adding, so you cannot just merge the values. Then you will divide the 120 by 4. So what does that give you?
30.
And
Plus 12 under root 5.
root 60 upon under root 5. Since this does not require rationalizing of the denominator, they're just one value is in the denominator and the other is in the denominator. We will try to factorize the numbers. So what are the factors for 60? Okay, so since the 2 and 2, they get multiplied. Okay. And so under root 4 becomes 2. What's left inside?
3 into 5.
3 into 5 upon under root 5. Can we cancel under root 5 and this?
Yeah.
Yes. So what's the answer? Yes. Very good. Okay. Then the question says if 3 power x is equals to y and 2 power x is equals to z, we need to express 9 power negative x times 12 power x in terms of y and z. So what will we have to do? We have been given two values, 3 power x and 2 power x. We need to bring them we have to bring these two values in that form. Okay. So what do we do first?
3 to the power 2, like 1 upon 3 to the
So
power
first just convert the 9 in terms of 3. What is 9 in terms of 3?
3 to the power 2.
2. And since we have negative x, so we will multiply that 2 with negative x. So what do we get?
Negative 2x.
Negative 2x. Okay. Then we are multiplying it by 12 power x. We have to bring it in terms of 2 and 3. Okay. So let's make the same index. Oshna, do you know when the indexes are same but the bases are different, what do we do?
We multiply the bases and keep the indexes same.
Like this?
Oh, yes.
Yes. So if I want to give this whole the power x, what do I multiply? How do you multiply values with base 2 and 3 to get 12? Let's just keep 1, 3 here. What should you multiply 3 with to get 12?
4.
4. And how do you express 4? Yes. Do you get this?
Yes.
Okay. Let's first convert this into a fraction. 3 power negative 2x. How do we do that?
1 upon 3 to the power 4 to the power 4. 3
2x?
to the power x.
1 upon 3 to the power 2x. Okay. Because we just removed the minus sign. Then multiplied by, let's bring this whole bracket in the numerator. So we are going to multiply it with 2 power 2x times 3 power x. Do you get why I did that? I multiplied this x with both. Okay.
Yes.
Then now start replacing them. 2 power x is z. So how do I replace it?
Instead of writing 2 to the power 2x, just write z and then y.
No, where did the 2 go? It's to the power 2x, not 2 to the power x. Here it says 2 to the power x. Z square and then times 3 to the power x becomes y upon
y square.
Y square. Can I cancel? Because they're multiplying. So does it become z square upon y?
Yes.
Yes. Okay. How do we do this?
अच्छा ये तो हो जाएगा 6 and plus 2 times 2 4 refers to 8 and 8 upon it would be 6 plus 4 6 and then plus 4
plus 4 and
4 6
4 under root 6.
yes
वो
जो plus 4
plus 4 okay
and then it will be 10 plus 4 6 we will plus 6 and 4 upon and then 8 upon 10 plus 4 under root 6 and then 8
the question says you need to rationalize the denominators. So what
yes,
do you do?
got it. Then we will multiply it with 4 under power 6 times minus 10 on
yes.
both minus, and then we will get the answer.
Yes. So tell me what's the answer. Not just saying that we get the answer.
I don't have a pen or paper right now.
8 4s are 32
32 and
under
then
root
minus
6
under root 6 minus 80. And then it will be
upon
4 upon
4 4s are 16. 16 times 6.
6 हो गया. Okay, got it. एक मिनट. This under root multiply होकर 60 हो जाएगा ना? And then 4 times 6 is 24.
Yes.
24 minus
4 times 4 is
4 times 4 is 16.
times 6 gives us 96. And then
we will do it 40
multiply.
minus 40 under root 6. Then we will do plus 40 under root 6. That will cancel both of them. And then we will do minus 100.
And then we will
Minus 100. 10 times 10 minus 100.
yes. And so
And then we will get upon minus 4 at the denominator. And then we could easily negative 4. Then we can easily divide both of them. We may get can we divide under root? Yes, we could get it. Then we could divide by minus 4 and we will get 32 divided by 4, 8 minus 8 under root 6 and minus 40, I believe 20. Yes, plus 20.
Okay.
Correct?
1 upon 9 power x plus 2 is equals to 3. Farah, can you solve this?
Yeah. Okay. So 1 upon 3 to the power 2. And then bracket outside the bracket we get x plus 2 equals to 3.
That 3 to the power 0 is 1 upon 3 square multiplied by x plus 2, which is equals to 3. All of us know that anything to the power of 0 is 1, so that's very clear, right? Okay. Then what do I do next? Okay, 0 time when you're multiplying 0 with x plus 2, what do you get?
0.
Then 3 2x plus 4. Do you get this? Is equals to 3. Now what do we do?
Take 3 on that side and we multiply it. We take 3
What
to
do
the
you
power
get?
2x plus 4. So we get 3 to the power 2x plus 4 plus 1.
So what's the answer?
2x plus 5 equals to 0.
You're multiplying them, so you add all the powers. 2x plus 5 is equals to 3 to the power 0.
We can cancel out the bases.
And then you're saying that x is equals to 2x plus 5 is equals to
0.
Are all of you understanding what's happening? We need to find x, right? That's the equation. So when we have 3 to the power 2x plus 5 is equals to 3 to the power 0. Since the bases are same, it means that 2x plus 5 is equals to 0, right? So 2x plus 5 becomes 0. And what does x come out as?
Minus 5 upon 2 or minus 2.5.
Negative 5 upon 2. Does everyone understand that?
Yes.
Okay, that's great.